Welcome back, developers. In this video, we're going to explore performance and optimization in React. So what do we really mean by performance and optimization in React? It's all about making your user interfaces faster, smoother, and more responsive. Optimized React applications minimize unnecessary re-renders, manage state efficiently, and reduce load times, ensuring a seamless user experience. In simple terms, it's about speed, responsiveness, and resource efficiency. Well-optimized React apps not only improve user experience, but also handle large-scale applications gracefully, keeping your UI smooth even under heavy usage. For example, avoid unnecessary re-renders of components using React.memo. Use lazy loading for components and images to improve initial page load. The first topic we'll cover is performance and optimization in React. This focuses on making React applications faster, reducing unnecessary re-renders, and ensuring smooth user interactions. Optimized React apps efficiently manage state, component rendering, and computational resources, especially important in large-scale or complex applications. How do you prevent unnecessary re-renders of a component? Answer: React.memo. Example: React.memo prevents a component from re-rendering if its props haven't changed. This reduces unnecessary work for React, keeps the UI responsive, and improves overall application performance. How do you cache heavy computations to avoid recalculating each render? Answer: useMemo. Example: useMemo memoizes the result of an expensive computation and recalculates it only when its dependencies change. This prevents repeated computation on every render, improving performance in data-intensive or complex components. React performance optimization isn't just about speed, it's about keeping the UI smooth, responsive, and efficient. We saw how React.memo prevents unnecessary component re-renders and how useMemo caches expensive computations to save processing time. In interviews, share examples of how you applied these optimizations in real projects, demonstrating practical understanding of React performance best practices. Now that we've set the stage, let's dive into the key principles of React performance optimization and see how you can make your apps faster, lighter, and more scalable. The first key principle in building high-performance React applications is avoiding unnecessary re-renders. This principle ensures components only re-render when needed, improving UI responsiveness and reducing wasted computations. By controlling re-renders, React apps become faster, more efficient, and smoother, especially in large-scale applications. How do you prevent a child component from re-rendering when parent state changes? Answer: React.memo. Example: React.memo memoizes a component so that it only re-renders when its props change. This avoids unnecessary updates and improves performance when parent components update frequently. How do you memorize a callback passed to children to avoid re-renders? Answer: useCallback. Example: useCallback memoizes functions so that children receiving them as props don't re-render unnecessarily. This is especially useful when passing callbacks to deeply nested components. Avoiding unnecessary re-renders is crucial for keeping React applications fast and responsive. By using tools like React.memo and useCallback, you ensure components update only when necessary, saving computation and improving the overall user experience. In interviews, be ready to share real-world examples where you optimize component rendering. This shows practical understanding of React performance strategies. The second key principle in building high-performance React applications is efficient state management. This principle ensures that updates to state only trigger necessary re-renders, keeping the UI responsive and minimizing wasted computations. By managing state thoughtfully, React apps remain scalable, maintainable, and fast, even in complex applications. How do you avoid unnecessary re-renders caused by global state updates? Answer: local state. Example: using local state confines updates to the component that needs it, preventing unrelated components from re-rendering unnecessarily. Which state management approach prevents prop drilling in large apps? Answer: Context API. Example: the Context API provides a way to pass data through the component tree without manually passing props at every level, reducing prop drilling and optimizing performance. Efficient state management is key to building scalable and responsive React applications. By using local state wisely and leveraging Context API where appropriate, you minimize unnecessary re-renders and simplify data flow. In interviews, be ready to share real-world examples of how you structured state to improve performance. It demonstrates practical mastery of React optimization techniques. The third key principle in building high-performance React applications is code splitting and lazy loading. This principle ensures that only the necessary code is loaded when needed, reducing initial bundle size and improving page load performance. By splitting code and loading components dynamically, React apps become faster and more efficient, especially for large-scale applications. How do you load a component only when it's needed to reduce initial bundle size? Answer: React.lazy. Example: React.lazy allows components to be loaded only when they are rendered, preventing unnecessary code from being part of the initial bundle and improving performance. How can you split routes in React to improve page load performance? Answer: dynamic import. Example: dynamic imports with React.lazy and Suspense allow route-based code splitting, ensuring that each page loads only the code it needs, optimizing load time and user experience. Code splitting and lazy loading are essential for reducing initial bundle size and improving page load speed. By using React.lazy and dynamic imports, you ensure that your application loads efficiently without unnecessary delays. In interviews, be prepared to discuss how you implemented lazy loading to enhance performance. It demonstrates practical understanding of React optimization strategies. The fourth key principle in building high-performance React applications is virtualization for large lists. This principle ensures that rendering thousands of list items does not slow down the UI by only mounting the visible items in the DOM. By using virtualization techniques, React apps handle large datasets efficiently while maintaining smooth scrolling and responsiveness. How do you render thousands of list items efficiently without slowing the UI? Answer: React window. Example: React window renders only the items visible in the viewport, dramatically improving performance for large lists. Which technique ensures only visible items are mounted in the DOM for performance? Answer: windowing. Example: windowing ensures that only the items currently in view are rendered, reducing DOM nodes and keeping the UI fast and responsive. Virtualization and windowing are crucial for handling large datasets in React applications. By rendering only visible items with tools like React Window, you minimize DOM updates and keep the UI smooth. In interviews, share examples where you implemented virtualization to optimize performance. It demonstrates practical expertise in building high-performance React apps. The fifth key principle in building high-performance React applications is avoiding inline functions and objects in JSX. This principle ensures that components don't re-render unnecessarily due to new function or object references being created on every render. By memoizing functions and objects, React applications become more efficient, reducing wasted computations and improving responsiveness. How do you prevent unnecessary re-renders caused by inline functions in JSX? Answer: useCallback. Example: useCallback memoizes the function, ensuring that children receiving it as a prop don't trigger unnecessary re-renders. How do you avoid creating new object references on every render in JSX? Answer: useMemo. Example: useMemo memoizes objects, so the same reference is used across renders, preventing unnecessary re-renders and improving performance. Avoiding inline functions and objects in JSX is key to optimizing React applications. By using useCallback and useMemo, you reduce re-renders and make the UI more responsive. In interviews, explain scenarios where you applied these techniques. It highlights your understanding of advanced React performance optimization strategies. The sixth key principle in building high-performance React applications is optimizing images and assets. This principle ensures faster page loads, smoother rendering, and better user experience by reducing the weight of visual content. Efficiently handling images and other assets prevents blocking of the main thread and minimizes bandwidth usage. How do you improve load times for images in React without blocking rendering? Answer: lazy loading. Example: lazy loading delays the loading of images until they are about to enter the viewport, improving initial page load performance. How do you reduce image file size for faster page performance? Answer: compression. Compressing images or using modern formats like WebP reduces file size, speeds up rendering, and improves overall performance. Optimizing images and assets is essential for fast, responsive React applications. By implementing lazy loading and compression, you ensure pages load quickly without compromising user experience. In interviews, highlighting real-world use of image optimization demonstrates practical React performance knowledge. The seventh key principle in building high-performance React applications is minimizing expensive computations. This principle ensures that heavy calculations don't slow down rendering or block the main UI thread, keeping applications responsive and smooth. How do you avoid recalculating heavy computations on every render? Answer: useMemo. Example: useMemo memoizes the result of a computation, recalculating it only when the dependencies change, reducing unnecessary processing. How can you move expensive logic out of the render cycle for performance? Answer: worker thread. Example: using a worker thread offloads intensive tasks to a separate thread, preventing the main UI from blocking and improving responsiveness. Minimizing expensive computations is crucial for smooth React apps. By using useMemo and worker threads, you ensure heavy calculations don't hinder rendering or user interactions. In interviews, be prepared to share examples where you optimize computation-heavy components to improve performance. The 8 key principle in building high-performance React applications is using Profiler and performance tools. This principle ensures you can identify bottlenecks, understand rendering behavior, and make informed optimization decisions. How do you identify which React components are causing slow renders? Answer: Profiler. Example: the profiler records render times for components, helping pinpoint slow or frequently re-rendered components. Which tools can you use to analyze React performance bottlenecks in the browser? Answer: DevTools. Example: React DevTools allows you to visualize component render performance and detect inefficiencies in real time. Profiling and using performance tools is essential for optimizing React applications. By leveraging the Profiler and DevTools, you gain insights into rendering behavior and can make targeted improvements for faster, smoother UIs. Next, we'll dive into best practices for performance and optimization in React, where we'll explore actionable strategies to make React apps even more efficient. The first best practice for performance in React is memoizing functional components. This ensures components only re-render when their props actually change, improving UI responsiveness and reducing unnecessary computations. How do you prevent a functional component from re-rendering when its props haven't changed? Answer: React.memo. Example: React.memo memoizes the component so that it only re-renders when props change, saving computation for frequent updates. How do you combine React.memo with the custom prop comparison function? Answer: are equal. Example: by providing a custom comparison function, you control exactly when a component should update, making memoization more precise. Memoizing functional components is essential for keeping React applications fast and responsive. By using React.memo and optionally a custom prop comparison function, are equal, you prevent unnecessary re-renders and save computation time. In interviews, be ready to share real-world examples where you optimize component rendering. This demonstrates practical understanding of React performance strategies. The next best practice for performance in React is using useMemo to memoize expensive calculations. This ensures that heavy computations are only recalculated when their dependencies change, reducing unnecessary processing and keeping your UI responsive. How do you avoid recalculating a heavy computation on every render? Answer: useMemo. Example: useMemo caches the result of the computation and only recomputes it when data changes, improving rendering performance for complex calculations. How can you memoize derived state from props for performance? Answer: memoized value. Example: memoizing derived state ensures that computations based on props do not run on every render, keeping the component efficient and reducing unnecessary recalculations. Using useMemo for expensive calculations is key to maintaining smooth React applications. By memoizing both heavy computations and derived state, you prevent redundant processing and improve overall performance. In interviews, highlight scenarios where you optimize computation-heavy components. This demonstrates practical knowledge of React performance optimization. The next best practice for performance in React is using useCallback to memoize event handlers. This ensures that functions passed to child components maintain the same reference between renders, preventing unnecessary re-renders and improving efficiency. How do you prevent child components from re-rendering due to changing functions? Answer: use callback. Example: use callback returns a memoized version of the callback that only changes if its dependencies change, keeping child components from re-rendering unnecessarily. How can you memoize multiple event handlers efficiently in a component? Answer: hook memoization. Example: using useMemo to memoize multiple handlers together ensures all functions maintain stable references, reducing re-rendering overhead for child components. Memoizing event handlers with useCallback and combining multiple handlers with useMemo is crucial for optimizing React applications. This approach prevents unnecessary re-renders and ensures efficient updates, especially in deeply nested components. In interviews, share examples where you optimized event handlers to demonstrate practical React performance strategies. The fourth key principle in building high-performance React applications is virtualization for large lists. This principle ensures that rendering thousands of list items does not slow down the UI by only mounting the visible items in the DOM. By using virtualization techniques, React apps handle large datasets efficiently while maintaining smooth scrolling and responsiveness. How do you render thousands of list items efficiently without slowing the UI? Answer: React window. Example: React window renders only the items visible in the viewport, dramatically improving performance for large lists. Which technique ensures only visible items are mounted in the DOM for performance? Answer: windowing. Example: windowing ensures that only the items currently in view are rendered, reducing DOM nodes and keeping the UI fast and responsive. Virtualization and windowing are crucial for handling large datasets in React applications. By rendering only visible items with tools like React Window, you minimize DOM updates and keep the UI smooth. In interviews, share examples where you implemented virtualization to optimize performance. It demonstrates practical expertise in building high-performance React apps. The fifth key principle in building high-performance React applications is avoiding inline functions and objects in JSX. This principle ensures that components don't re-render unnecessarily due to new function or object references being created on every render. By memoizing functions and objects, React applications become more efficient, reducing wasted computations and improving responsiveness. How do you prevent unnecessary re-renders caused by inline functions in JSX? Answer: use callback. Example: useCallback memoizes the function, ensuring that children receiving it as a prop don't trigger unnecessary re-renders. How do you avoid creating new object references on every render in JSX? Answer: useMemo. Example: useMemo memoizes objects, so the same reference is used across renders, preventing unnecessary re-renders and improving performance. Avoiding inline functions and objects in JSX is key to optimizing React applications. By using useCallback and useMemo, you reduce re-renders and make the UI more responsive. In interviews, explain scenarios where you applied these techniques. It highlights your understanding of advanced React performance optimization strategies.